Good morning, guys. Anjani Kumar here, dealing power system 2 for third year electrical students, right? In the last session, we discussed about brief review on total unit 2 regarding sag, tension, and the concept of insulators, string efficiency, methods to improve the string efficiency, right? That we discussed on some sort of problems also we discussed, right? We discussed about brief things in our last session. In this session, we are going to start the fresh unit called various factors affecting the performance of a transmission system. I think this is unit 4 or 5, I don't know. So that is the name, factors affecting performance of transmission line. Very, very important. Nothing is there, right? If you follow my videos, it will be very clear for you guys what are the factors that are going to be affect when a conductor carrying the power, right? Till now, we discussed about how we can erect the transmission system. So till now we discussed about, so what is a transmission line, right? So what are the different types of a transmission line? There is a short transmission line, a medium transmission line, and a long transmission line, right? After that, we discussed about how the transmission line is going to be erected between the two transmission towers, right? So it may be tightly connected or else loosely connected. Tightly connected, some advantages, loosely, so why we need, so that's why we need to maintain a sag. So between the conductor and the transmission line, we need to maintain some sag, and also we need to maintain the sag tension also. So these are the construction oriented issues. And also we discussed about how the proper insulation between the transmission and the conductor, right? So we discussed about different types of insulators also, and how the string efficiency is developed. So till now we discussed about total erection of a transmission line, right? Now we erected your transmission system, right? Your conductor, whatever the conductor in a transmission line which is carrying the voltage or current, it is carrying the current. Now if it's carry the current or a voltage, what are the factors that are affected in a transmission system? We should know. Okay, you are transferring the power from a large distances for a large distances, either a distribution system or a transmission system. We need to transfer the power. While transferring the power, so what are the disturbances? What are the effects? What are the factors that are affect while transferring the power? So there are 4 categories. There are 4 parts. The first part is a skin effect. Very, very important concept, right? The first part, the total unit consists of 4 parts, but we definitely discuss about all these 4 parts in detail, no doubt about that, right? If you follow the videos, these are our technical considerations. Each and every power system engineer must know these type of a concept, right? The first concept is a skin effect. In the skin effect, what is a skin effect? What are the factors affecting the skin effect? Factors affecting the skin effect, right? So what are the disadvantages? How to reduce the skin effect, right? So this we will discuss, right? In this session we will conclude the skin effect concept, right? And the next another effect that we are consider while power transmitting to a transmission system, that is called proximity effect. In this, what is a proximity effect? So what happened if these type of effects present in the system? What are the losses that you are going to consider? Alright, let's we discuss about proximity effect. Next, Ferranti effect. Right. What is a Ferranti effect? Well, power transferring from sending end to receiving end, how the voltage changes. Right. These are the things that we discussed under the concept of Ferranti effect. Next, the last most important concept is corona. Right. So what is a corona? Right. So what are the effects due to the corona? Effects due to the corona. And with the help of corona, we need to discuss two phenomena, right? Critical descriptive voltage and visual descriptive voltage. Right. So these are the things that we need to discuss in our unit. So the name of the unit is the factors affecting the performance of a transmission line. Now, while a power transferring from the transmission system, what are the effects that we need to consider? So there are 4 effects. So we need to consider. So what are the effects? Is nothing but a skin effect. And second one is a proximity effect, and the third one is Ferranti effect, and fourth one is the most important one as a corona. So in this corona, critical descriptive voltage is there, and visual descriptive voltage is there. We discussed in detail, no doubt about that. Alright. So these are the things that we need to understand. Every power system engineer must know what are the effects, right? We just have at least brief idea on that. These are very interview questions. While enter in a technical field, the questions will be like this: what is a skin effect in a transmission system? What is a proximity effect in a transmission system? What is a Ferranti effect? What is a corona? So these are real life. You will see these are real life examples. But you people don't know. So this is a corona or this is a skin effect. Definitely in each and every power system, we will get these type of effects. Right. Now we will discuss about the concept of skin effect. Very important, right? So better to follow this. Right. So in this skin effect, we are going to discuss first definition. Right. Second one, how it will happen. Right. Third one, disadvantages. And the fourth one, factors affecting the skin effect. And the fifth one is how to reduce the skin effect. Right? These are the things that we need to define in the concept of skin effect. Right? So first we discuss about a definition, or else first we will discuss how it will work. Right, how it will happen, and then you will define yourself for the definition of a skin effect. No need to buy out these definitions, right? What are the disadvantages? After that, what are the factors that are affecting this skin effect? What is the cause for this skin effect, and how to reduce the skin effect that we discussed here. First, we know, before going to definition, I hope it's clear for you. If you know the working, if you know how it will happen, then you will define your definition, right? Now, you know the conductor. So how the conductor, if you take the cross-sectional area of a conductor, the conductor will be like this. Right? So this is a conductor. Right? So each and every conductor is made up of different layers. Right? If you see that transmission line conductor, aluminum conductor, you will see the conductor on top, which is having a different layers are clumped together. Right? You will see, right, it is having a different layers. For suppose if you assume these are the different layers, right? So this is a conductor, cross sectional area of a conductor. Each and every conductor which is having a different layers. So these are the layers, right? Right. You know the Ampere's law. When current flowing through the conductor, what happened? There will be a magnetic field around the conductor, isn't it? Right? You know the Ampere's law. So what's the Ampere's law? So when a current flowing through the conductor, according to the current direction, the flux directions will be there. So if the conductor direction, current direction is like this, the flux direction will be like this. If the conductor direction is so the flux direction like this. Now the direction of flux will be like this. Right? The same phenomena. Now this is a conductor. The conductor which is carrying the current. So while current passing through the conductor, there will be a flux will be developed around the conductor. So each and every layer that it has some flux. Now the current flowing through the conductor, right, in the center part of the conductor there will be a flux. The flux direction will be, for suppose conductor current direction like this, the flux direction like this. This is the flux direction, right? And one more layer, this is the flux direction. Each and every layer that it has some current. So when a current flowing through each layer means there will be a flux around this. The direction of flux gives by Fleming's law. So how if the current direction, there will be a flux direction, right? In this layer the flux direction will be like this. In this layer the flux direction will be like this. This is a surface, right, top of the layer which is having the current flux direction like this. Nothing is there. When current flow through the conductor, each and every layer there will be some flux, right? How the flux's direction will be, you know the Fleming's law. You will see, right? Now see the concept. At the center, at the center of the conductor, you are having a maximum flux. The flux in the center should be very high. So this flux, that flux, and that flux, these are clumped and engaged at the center, right? That means the center, you will see the center more number of flux. While moving towards the surface, your flux linkages, your flux will be very less. I hope it's clear. Center low number of conductors are twisted, right? The layers are more layers. So if more layers means more inductance, more flux present in the center of the conductor, right? Goes on, your flux will be reduces. Only the flux values are very less, right? First we'll see at the center. Right, at the center, what about the flux? Flux linkages are high, right? At the center, your flux linkages are high. If the flux linkage is high, you know the formula, L is equal to psi by I, right? Where psi is flux linkages, I is a current flowing, right? So whenever the flux linkages are increases, so what about the inductance? Your inductance value will be increases at the center of the conductor, right? Your flux linkages increases, your inductance increases. Your inductance increases, what about the inductive reactance? Omega L, so that is nothing but 2 pi f L, right? If inductance increases, what about inductive reactance also increases now? I hope it's clear, right? If inductance increases, inductive reactance will be increases, right? If inductive reactance increases, what about a ZL? inductive impedance, right? JXL, right? So if XL increases, what about impedance? ZL will be increases, right? Then what about the current? I is equal to V by ZL. If ZL is increases, what about the current? Current is reduces. So that means it's clear from this, at the center of the conductor, the flux linkages will be very high. That means the current value will be very less. I hope it's clear. We'll see one more time. At the center, you will have a more flux, right? While traveling and going to the surfaces, that flux value will be very less, right? So the flux linkage is very high means, what about the inductance? Inductance will be very high. If the inductance is very high means inductive reactance value will be very high. If the inductive reactance value will be very high means the inductive impedance value will be higher. If impedance is increases, the current value is going to be reduces. So what we conclude that the near the conductor, near the surface, at the center of the conductor, the current value will be very less, right? I hope it's clear. At the center of the conductor, your current value, the current flowing through the conductor will be very less, right? Now we'll move on to the surface of the conductor. At the surface of the conductor, right? At the surface of the conductor, what happened? Your flux linkages will be less, because as a center more cloud is there now. So more cloud is there means there will be a more flux engaged, right? While moving to the surface, your flux linkages will be very less. So that means your flux linkages are less. So what about the inductance? L is equal to psi by I now. If psi is reduces, what about the inductance? If inductance is reduces, what about XL inductive reactance? 2 pi FL. If L is reduces, what about the inductive reactance also reduces? If inductant reactance reduces, what about the inductive impedance? JXL. Or is there we need not to consider, right? If XL is reduces, what about the inductive impedance is reduces, right? So if inductive impedance is reduces, what about the current? What about the current? If it is reduces, the current value will be increases. So this is the factor. On the surface of the conductor, your current is increasing, right? So what we conclude? Conductor, the current will increase, right? So on the surface of the conductor, the flux linkages will be very less. If the flux linkages will be very less means the inductance value less. If the inductance is less means inductive reactance also reduces. If the inductive reactance reduces means inductive impedance also reduces. If inductive impedance reduces, what about the current? The current value will be increases. That means on the surface of the conductor, you are getting a maximum current, right? On the center of the conductor, you are getting a very less or minimum current. So this phenomena we can call it as a skin effect, right? I hope it's clear. You will define yourself, right? If this is a conductor, right, on the surface of the conductor, right, on the surface of the conductor you will have the current value, right? And the center of the conductor, we don't have a current, you don't have any charge value, right? So this phenomena we can call it as a skin effect, right? Now we'll define what is a skin effect. So it is a phenomena states that the current at the surface of the conductor is high and center of the conductor is less, right? So this unevenness of a current we can call it as a skin effect. I hope it's clear what is a skin effect. So if you want to define a skin effect, we need to know what is current near the surface of the conductor and what is the current at the center of the conductor. So from the figure itself, you will see the surface of the conductor, you are getting a maximum current. Near the center of the conductor, you are getting very less current. The unevenness of a current, we can call it as a skin effect present in the system. Alright? I hope it's clear, right? So one more definitions are there. So what are the definition? From the phenomena states that from the center of the conductor to the surface of the conductor, your flux linkages value will be very. Right? I don't want to write that definition. Okay, I'll write it. Right? So the definition 2. Right? Definition 2. So phenomena states that the flux linkages from the center of the conductor to the surface will be reducing. Right? So the unevenness of the flux linkages, we can call it as a skin effect. Or else we'll discuss one more definition is there. We'll discuss further. Right? So this is when AC supply is given to the conductor, how the conductor behaved. Now we are giving a DC supply. So at the starting I said we need to transfer the high voltages. We need to transfer the power for a large distance. We require DC supply. Right? We can't transfer the AC supply for a longer distance. Why? Because if you supply AC, that means the conductor number of conductors will be 3 phase, 4 wire, 3 phase, 3 wire. So number of conductors will be very high. That means cost is increasing. That means in the case of AC, we have a frequency components. There will be harmonics will be developed. That means due to the losses will be created. And one more, the conductor cross section area will be reduced while transferring the power with the help of DC. Alright, so these are the phenomena. These are the things that use it to transfer the power for a large distance. We require a DC supply. So I already explained with the help of DC how the skin effect will be. We'll see. Right, skin effect in DC transmission lines. Right. You know that. So what is the XL value for a center of the conductor? What is the XL value? 2 pi FL. In a DC, what about the frequency is equal to 0 now? Right? If a frequency is equal to 0, is there any inductive reactance? There is no inductive reactance. There is no inductive reactance. That means what about the inductive impedance? That is equal to R plus JXL now. So R plus JXL means JXL value 0. What is the impedance value? R. Right? If surface of the conductor XL also 2 pi FL now, is there any frequency? XL is equal to 0. So what about the ZL? ZL is equal to R value. So that means in DC lines, how it will be, we'll see. These are the different layers. Right. Near the surface, what about the resistance value will be R. So what is the current value? V by ZL. So that is nothing but I is nothing but same, right? So when you come to the surface of conductor, the ZL impedance will be the same. So same current will be flow, right? V by R. The same current will be flow. So near the surface of the conductor, the resistance value will be R, and goes on near the center of the conductor, the resistance will be R, and goes on to the surface. Near the surface of the conductor also, the resistance will be R. The effective resistance is not disturbing. The current is also equal. That means here the value of resistance is R. Here the value of resistance is R. Here the value of the resistance is R. The impedance is constant. So that means the current is also constant. So that's why in a DC supply, so we don't have that much effect of skin effect. So that means the note is, right, the effective resistance is constant. Effective resistance is constant from center to surface. So center to surface effective resistance is constant means what about the current value? The current is also constant. Current is also constant. So there is no unevenness of a current. So there is no problem of skin effect in DC. So that's we need to write it here. No effect of skin phenomena in DC line. DC transmission line, whatever it may be, DC transmission line. Very, very important. Why? Because the resistance value will be the effective resistance value from the center of the conductor to the surface, which is equal. There is no unevenness of the resistance. There is no unevenness of the current. So throughout from the center to the surface, the current is a constant value. That's why the effect of a the effect of a skin phenomenon in a DC transmission line should be 0. So these are the advantages. This is also one of the advantages while transferring the power with the help of DC lines. Alright. Now we'll go for another definition. How to define skin effect. You will see. So the definition number 3. Alright. Right. You will see. So what is the skin effect? The center you are having a minimum current, and from flowing the surface the current value will be increases. This unevenness of current we can call it as a skin effect, right? So that means the center. So what about the resistance value? Right? At the center you are having a minimum current na. So minimum current means resistance value will be. So what about the resistance value? So current is minimum means the resistance value will be increases, right? So at the surface the current is maximum. So if the current is maximum means resistance value will be reduces. So the definition is the effective resistance will be reducing from the center to the surface. So this is one more definition, right? The effective resistance will be or else increasing from the surface to the near, right? Will be increasing from the surface to center of the conductor. Alright, so here we'll get the minimum resistance, and the resistance goes on increasing. At the center we'll get the maximum resistance. Then only the current will be less, I less. Here I will be increasing. So the effective resistance will be increasing from the surface to the center, right? Now what is the disadvantages you will see. So you will see now the power is transferred to a transmission system, right? Before sending the power, the transmission line which is having a resistance now, if resistance value will be 5 ohms, alright? So while transferring the power, the resistance value will be increases 10 ohms, because on the surface it will be very less and goes on increasing, right? So when the power transfer to the conductor, the effective resistance value will be increases. If the effective resistance value will be increases, means the I square R value increases, copper losses I square R value increases. If the losses increases, so what about the efficiency? Efficiency reduces. What about the voltage regulation? Reduces. So these are the effects. So while skin effect considered in a transmission system, so these are the effects that we need to take care. So skin effect, if the skin effect is present, the effective resistance will be increases. If the effective resistance will, this is the before the power transferred. So when a power transferred, the resistance value will be increases due to the unevenness of the current. So if the resistance value increases, means the copper losses will be increases. If the copper losses increases, what about the efficiency reduces? That means voltage regulation is reduces. This is the disadvantages. So while presenting the corona effect in a transmission system. So this is up to now. So we discussed about how the phenomenon takes place in a conductor, and what is the definition of a skin effect. And after that we discussed about in a HVDC system why the skin effect is eliminated. And after that we discussed about what are the disadvantages while considering this skin effect, that we discussed in this session. Alright, I think I hope it's clear. This is a very simple phenomena. In the next session we discussed about what are the factors that are affecting the skin effect and how to reduce this effect, that we discussed in the next session. Thank you for now.